chapter 3, metals and non-metals. We are doing revision, preparing for your test, right? This is session 3, the final session, all right? It's going to be the final session, all right? So the whole chapter would be revised. Now, in this session, we are going to see metallurgy. In previous session, I described or explained the chart of metallurgy, right? Now, in metallurgy, now what is metallurgy? Extracting metal from its ore by removing impurities one by one. From where do we get the ore? We get ore from the earth crust, correct? Okay. Then it is taken to the industry. Now this metallurgy, that is obtaining metal from its ore, is a continuous process, but it is divided into 5 stages, 5 parts for understanding it in a better way. Alright. So first what is done? Powdering. The ore is taken to a huge industries. Okay. And in this industries, big mills they call. Okay. The ore is powdered. It is ground into powder. Alright. Once that is done, the other method is concentration of ore. Means increasing the percentage of metal which we are going to extract from its ore. Alright. Now, ore can be concentrated in different ways. And we learnt about 3. One is centrifugation. Now, in centrifugation, there is big difference in densities. Big difference in densities. Alright. जो metal है और impurity है, दोनों की densities में बड़ा difference है, बड़ा अंतर है. Then that is concentrated by centrifugation. The impurity is separated from the ore. Alright. By a process called centrifugation. I've explained to you in detail earlier, correct? On a round table, this powdered ore is spread and this table is rotated. In the center there is slot. So what happens? Yes, impurities moves towards the slot and it is collected in the center of the table. Whereas the ore falls off because of higher density. So when there is big difference in densities, centrifugation is used. You remember that. Froth flotation, that is sulfide containing ore. If the ore is sulfide containing, then it is concentrated. There is increase in percentage of ore, metal in the ore by froth flotation. What is done? This sulfide containing ore has impurity of sand, right? Now sand gets wet with water, but sulfide ore doesn't get wet with water. It gets wet with turpentine. So in a container, alright, in a device, the mixture of water and turpentine is taken. And in this, the ore is dropped. Powdered ore is dropped. Concentrated ore is dropped. Alright. In fact, not concentrated. Here we are concentrating. So the powdered ore is dropped. Alright. So what happens? The sand very soon gets wet with the water and becomes heavy and settles down. And soon sulfide ore, which doesn't get wet with water, gets wet with turpentine and becomes heavy. It also moves down and settles on the sand. Now when that is happened, alright, what happens? Yes, pressurized air is introduced into the mixture. So what happens? The froth of sulfide, okay, is formed and it comes and floats on the surface of the water, which can be easily removed or separated. So this is how concentration is done by froth flotation. Magnetic separation, very easy. Magnet is attracts the iron. So if any iron impurity is there in the ore, then that iron is removed with the help of magnet. Yes, the powdered ore is dropped on the belt which keeps on rotating. At one end there is magnet. So what happens? As the powdered ore passes through this second wheel, which is made up of magnet, all the ore except the iron falls straight away down, whereas the iron in the ore gets stuck to the magnet and it moves along with the belt ahead. And then when it moves away from the wheel, what happens? The iron also falls because it moves away from the magnet. So that force of attraction is lost and it falls. So two hips are formed, one of ore and other of iron powder. Okay, so that is how iron is separated by magnetic separation. And since iron is removed from the ore becomes concentrated. The percentage of metal in it increases. So that is about concentration. Now once the ore is concentrated, what is done? What is the next stage? Roasting, calcination and smelting. I shall not discuss about this in detail because it has been explained in the first video. Right? Roasting. Yes, that is heating the concentrated ore in excess of oxygen, in excess of air. And metal ore, the ore is converted into metal oxide. Okay. Calcination. Yes. Roasting is done on sulfide containing ore. If the ore is sulfide containing, it is heated in excess of presence of air, and yes, that ore gets converted into metal oxide. Calcination, if carbonate containing ore is there, then it is heated in absence of air. Alright? And this carbonate containing ore gets converted into metal oxide. And the other one is smelting, that is ore is taken in liquid form and then heat is given. So some impurities are removed in the form of vapor. Alright? So that is smelting and you get metal oxide at the end of the process. Okay. So this gives you, from ore you get metal oxide. From ore you get metal oxide in all these three processes. Clear? Okay. Now what you have? You have got metal oxide. You have got metal oxide. So reduction is done. In this reduction, metal oxide is reduced to metal. Metal oxide is reduced to metal. Please remember these three examples. Zinc. So zinc oxide, that is ZnO. Manganese dioxide, that is MnO2. Iron, ferric oxide, that is Fe2O3. Children, these are treated with carbon. उसको कार्बन के साथ ट्रीट करते हैं. So it produces zinc. Zinc oxide से zinc बाहर निकल गया and carbon monoxide. This also produces manganese. And manganese के बाद carbon monoxide. This produces iron. From iron oxide, iron is removed and you get carbon monoxide. Children, so this carbon reacts as reducing agent. It reacts or it acts as reducing agent. So zinc oxide, manganese oxide and iron oxide या ferric oxide are reduced by carbon या coke. Alright. Now children, from this iron oxide, alright, and manganese dioxide, depending upon the impurity, it may not be reduced by carbon. Let's take example of ferric oxide, Fe2O3. Now, the impurity present in it is such that it cannot be reduced by carbon. Then, they take carbon monoxide as reducing agent. So, when ferric oxide not reduced by carbon, then it is reduced by carbon monoxide. And carbon monoxide will work well and produce iron here. But instead of carbon dioxide, instead of carbon monoxide, here you are going to get carbon dioxide. So this is how reduction is done. Children, sure? Now, this manganese dioxide and ferric oxide, if they are not reduced by carbon nor by carbon monoxide, then they are reduced by another metal which is more reactive than manganese or iron. Just see, children. This manganese dioxide and ferric oxide, they are neither reduced by carbon nor by carbon monoxide. So you will need metal which is more reactive than metal present in the oxide. Here manganese is there, here iron is there, and that metal is aluminium. Aluminium is more reactive than manganese as well as than iron. So what happens? What is produced? Yes, manganese is substituted by aluminium. So manganese is removed. This is substitution method. Or aluminium oxide will be formed. Al plus 2 O minus Al plus 3 O minus 2. So you get Al2O3. Same way, iron is removed here, substituted, because aluminium is more reactive than iron. Aluminium is more reactive than manganese. So substitution reaction takes place. So iron is out and aluminium combines with oxygen producing aluminium oxide. Al2O3. Is that clear, children? Okay. So that's how reduction is done. 3 stages. Those metal oxide which can be reduced by carbon. Okay. Then not reduced by carbon, then it is treated with carbon monoxide. Okay. And if the metal oxide is neither reduced by carbon or carbon monoxide, then it is reduced by more reactive metal. लेकिन children, ये ऑक्साइड में जो मेटल होते हैं वो खुद वेरी रिएक्टिव होगा. इफ इट इज वेरी रिएक्टिव तो उससे ज्यादा मोर रिएक्टिव मेटल से भी वो रिड्यूस नहीं होगा. then such metal oxides are reduced by electrolysis. तब उसको इलेक्ट्रोलिसिस से रिड्यूस करते हैं. So reduction takes place in 4 ways. First, reduction by coke या carbon. Second, reduction by carbon monoxide. Third, reduction by metal which is more reactive than metal present in the oxide. And fourth, electrolysis. All right. Next is refining. So after reduction you got metal, but this metal is not 100% pure. There are still some impurities present. It may be 90 to 95 or 90 to 99% pure, but still 1% to 5% of impurities present in it. And if you want to remove that, all right, if you want to use it for medicine preparation, if you want to use it for experiment research, all right, then those metals are required in 100% pure form. And if you want to get 100% pure metal, then you will have to go for the last stage, and that is refining. Now this refining is done by 3 ways depending upon the nature of metal. Electrolysis, just now I said, this metal oxide, सीधा metal हम electrolysis से pure 100% form में ला सकते हैं जो highly reactive metal है, correct? And liquefaction. Liquefaction, if the metal has low melting point, ये metal में low melting point हो, then yes, ये सीधा connection है दोनों नेम से, low melting point, so it melts easily, so it turns into liquid. That's why it's called liquefaction. Okay, on a preheated slope, metallic slope, the powdered metal, the metal obtained after reduction is powdered and dropped on it. Now the impurity doesn't melt, but the metal, because of its low melting point, melts, and that melted metal runs down the slope and it is collected in a container, where else the impurity remains there. Or even the strainer can be kept, so impurities will be remain in the strainer. So that's how that small amount of impurity which was present is removed out. That process is liquefaction. You see the diagram, see the video. Zone refining. Okay. It is done by fractional distillation. Fractional crystallization. Fractional crystallization process. There is not much given to you in your book. Only it said it is done by fractional crystallization process. Alright, crystals are formed there. That's why it is called fractional crystallizations. Actually, there is difference in melting point of impurity and the metal. So what happens? Well, it is dissolved in solvent and then it is allowed to cool, but while cooling, the impurity cools faster and forms crystals, and these crystals can be removed, whereas the metal still remains in liquid form. So their melting point, boiling points are different, and as a result, what happens? Once you melt them, or dissolve them in solvent and then allow, yes, while dissolving we'll have to heat it so that it dissolves faster. And then when you allow the solution to cool down, the impurity forms crystal, whereas the metal still remains in liquid form. Okay. Now this impurity forms crystal and it can be separated by straining it. Okay. So that is fractional crystallization. Different fractions of crystals you get. That is zone refining. I hope you understood that. Alright children, now let's see what things to remember. Okay, remember first, all metals except mercury exist in liquid state at room temperature. Alright, metals are generally solid. There are no metals which exist in gaseous state at room temperature. And only one metal exists in liquid state at room temperature, and that is mercury. Next, lead and mercury are comparatively poor conductors of heat. We have seen the physical properties of metals. They are good conductor of heat and electricity. But when you talk about these two metals, lead and mercury, comparatively, they are poor conductors of heat. 1 gram of gold can be drawn into 2-kilometer long wire. That is about ductility of metals. You know, metals are ductile. That means they have property of being drawn into wires. Now gold, it is so highly ductile that if you take just 1 gram, you can prepare a wire of 2 kilometers length. Gallium and cesium have comparatively low melting points. Yes, another physical properties of metals. Metals generally have high melting point and boiling point. But here are two examples, gallium and cesium. They have comparatively low melting points. Okay. Iodine is non-metal, but it is lustrous. Yes, children. I missed out this point while discussing the physical property of metals. Metals are generally lustrous. They shine when you rub it. Correct? They have shining surface. Non-metals don't have. But here, iodine is non-metal, so it should not have luster. But iodine, though non-metal, possesses luster. So iodine is lustrous. Alright, remember all these examples. Any objective can be asked. Diamond, graphite and fullerene are allotropes of carbon. Yes, what do you mean by allotropes? Yes, they have same physical property but different chemical property. They are made up of carbon. ये diamond हो, graphite हो, fullerene हो, they are all having carbon atoms in their structure, nothing else. Carbon के अलावा कोई और atom नहीं है. But still they exhibit different properties because the arrangement of atom in them are different. Alright. Lithium, sodium and potassium can be cut with knife. Again, these are metals, so they should be very hard and durable, alright, strong. But these three metals, sodium, lithium, sodium and potassium, they are so soft that you can easily cut them with knife. Interesting, isn't it? Chal. Most non-metal produce acidic oxide. You know, non-metal reacts with oxygen. That is when they are burned, they produce non-metal oxide. Mostly these non-metal oxides are acidic in nature. And contrary to that, metals, when burned, produce metal oxides. Now these metal oxides are generally basic in nature. Alright children? Okay. So we'll keep this session short. Alright. Well, wish you all the best for your test. Hope you are preparing it well. So that's all in this session. See you in the next session. Till then, goodbye.